Wait, but if you think about it, you know how we've never had questions before? We've had more questions because we didn't finish the answers.
Yeah.
Yeah, I know. Be quiet, let's finish these.
We're gonna have more questions.
Wait.
All right, vertical angles. Vertical angles occur when you have two lines that intersect. Okay? So we're going to have two lines that intersect. And basically, if let's call this angle 1, all right? Now let's call this angle 3. And then let's call this angle 2. And we'll call this angle 4. And if you look, basically, the measure of angle 1 is equal to the measure of angle 3, right? And then the measure of angle 2 is actually equal to the measure of angle 4, okay? And so that's really the vertical angles theorem, and we're going to prove that in example number 1. So the way that we do that is, we're given some information. So let's let me slide that down here. We're given the fact that, what do you know about angle 1 and angle 3?
They're equal. Their measures are equal.
Yeah, so given angle 1 and angle 3 are vertical. Vertical angles. And what they want us to do is they want us to prove angle 1 is in fact congruent to angle 3. So I just said that they were, but we didn't prove it yet. So let me prove it to you. Look at this picture. All right. So we're going to start with a statement. And then we're going to give a reason or justification for the statement. And so the first thing that they say is that angle 1 and angle 3 are vertical angles. And that was given. Now remember, through this whole process, we're going to end up with this. So I know what the answer is. I just got to figure out how to get there. All right? So now, let's think about this. What do you know about angle 1 and angle 2? What do you know about angle 1 and angle 2?
Supplementary.
They're supplementary, right? They're on a line, so they're supplementary. So I'm going to say angle 1 and angle 2 are supplementary. I guess you could call them a linear pair, right? But, and you could say that they're a linear pair, and we did that proof yesterday. Linear pairs, well, they're supplementary. Okay? Well, that's the first thing. So now if they're supplementary, what does that tell us? Angle 1 plus angle 2 equals 180 degrees, right? And so that's a further justification of supplementary. All right? Now consider this. Angle 2 and angle 3 are also supplementary. If you look at the image, right? Angle 2 and angle 3 are also supplementary because they're also a linear pair. Okay? So, are supplementary. And so we would say linear pair. All right? And so then that would mean that angle 2 plus angle 3 is also equal to 180 degrees, right? And so that's because linear pairs are supplementary. Okay? So this is equal to 180. This is also equal to 180. So what can I say or do? I could say angle 1 plus angle 2 is equal to angle 2 plus angle 3.
So that's the
And that would be the transitive property, right? And some of you might be guessing, well, isn't that substitution? Yeah, it's kind of substitution too. Right? Now, what do we do? What's the next step? Well, couldn't I say subtract the angle measure of angle 2 on both sides? This cancels with this one, this cancels with this one, and I get angle 1 is equal to angle 3. That's the property of subtraction. And that's our proof. That's what we were asked to prove. Hey, look, we got time for example number 2. Any questions on that?
Wait. Is this the exact thing that's in the book? Yeah.
Yep. So now that we've proven that, let's apply it. Okay? So for the actual example number 1, what we have is we have a pair of vertical angles, perfectly drawn vertical angles, right? And I'm going to write this in a little bit here so you know that they're vertical angles. Whenever you have two lines that intersect, it makes vertical angles. That's it, every single time. And the vertical angles are nothing more than angles across from each other. So the measure of this length is 2x plus 21 degrees, and the measure on the other side is 4x degrees. How do we find x? What do we know? We don't have to prove it, we just have to do the math. Well,
subtract 2x from both sides. So
yeah, so, well, first let's be a little more formal. We know that this is equal to this because they're congruent angles, because they're vertical angles, right? So then we would subtract 4x from both sides, or I mean 2x from both sides. And I get 21 is equal to 2x. Hey, that doesn't look good. Well, that's a crazy answer. But then I would go through and divide both sides by 2. And my answer is 21 over 2. That's weird, isn't it? Now, normally I would tell students, hey, whenever you get some goofy answer like 21 divided by 2, you might want to double check your work. But it's only a two-step equation, and I don't think I made any mistakes. And it's the same answer the book had. We can have crazy answers, right? 21 over 2 is an answer. We may not like it because it's a fraction and it's weird. But we can't reduce it because the prime factorization of 21 is 3 times 7, and 2 is already a prime number. So I can't reduce it or anything. That's the answer right there.